and think they're not like terms, which they are not like terms. You're right. That's correct. But in terms of distributing, you can distribute this. When you go to distribute it, of course, you know the x times the 2. Okay? Now, when you distribute the x and the y, when you multiply a positive x times y, all it is it's just going to stay like that. Okay? Well, now when you go to actually combining them, typically the coefficient's written first, so I'm going to write 2x. And with the x and y, it doesn't matter which one comes first. You would just do plus x and y. Those terms would be combined now. So you can multiply or distribute that x and the y. They can combine terms right there. They're not considered like terms, but in terms of distributing, yeah, you can definitely distribute that. Now, let's go with I like this better. Okay, when you go to distribute this, all I'm doing is multiplying the 4 times the negative c and 4 times the 11. Okay? Pretty basic. So this is going to become 4 times the negative c plus 4 times 11. And when you go to simplify it, this really becomes a negative 4c, and this becomes 44. Any questions on that? Distributing. Whatever's on the outside, you're just multiplying it times each term on the inside. Let's say if it's a little bit backwards. Let's say if I have say if I have this, what would I do here? Yeah, it doesn't matter if it's on the left or the right side, yeah. You would just distribute the same way. And you would multiply anything out on the outside of the parentheses, 2 times the x, and 2 times 2. That's a different look that you might see.
I thought it looked like you would just put x plus 2, which is 2x, and then just plus 2.
No. Because that, if you think about it, that 2...
Or times 2.
Yeah, times 2. This 2 right here is telling you that you're multiplying times this, essentially this expression over here, this x plus 2. Okay? So it's still the same way, still distributing, just flipped on the other side. Just a different look. Still the same process, same procedure. Now, let's talk about like terms. I'm about to clear this, is that okay? Are these considered like terms? Yes, write this down. Are these considered like terms?
Yes.
Could I combine them?
Yeah.
Yeah, that's right. Now, when I go to combine them, am I adding the C and the C and the D and the D? No. The only term that you add or subtract is the number in front. They call it the coefficient. Okay, so really, essentially, this is just only 4 plus 3, which gives me 7. And it doesn't become c squared or d squared, it just stays the same. Right? Let's say if I have what about this? Like terms? Are they?
Would you multiply the exponents?
Would I? What you think? Anybody else?
Well, you're adding them when they're
Just go off. I'll do that.
As long as you are adding or subtracting, you do not even mess with those exponents. So this becomes 8c squared. Okay? Sorry, that's an ugly C. Yes, the c squared stays the exact same. You don't add the 2 plus 2 right there. Or you don't multiply it, or you don't even mess with it. When you're just adding or subtracting, only term you mess with is the first term. They call it the coefficient. Let's try something else. Where's this first one? What do I do here?
Add.
Yeah, only terms you add is the 2 and the 3. The d squared stays the same. So this becomes 5d squared. Okay? Yes, Freddie.
What if the letters?
I like the way you're thinking. Yeah. Let's say if we have 4c to the third plus 10 c to the second. Are these considered like terms?
Yeah. No.
Why not, or why? Why do you think not,
They don't.
Freddie? If they have different exponents, like they have the 3 and the 2 here, even though they have the same variable, these are not considered like terms. These are considered unlike terms. So, in that case, do you think I can combine them? No. So this would actually be considered simplified. That would be considered simplified. Have to have the same variable. Have to have the same exponent. Always, always. Like terms. See if I can trick it up a little bit. Are these considered like terms?
Yeah.
Why?
They both have the same exponents.
They both have the same exponents and have the same variable. Absolutely. They both have a c squared, and they both have a d to the third. So what am I going to do here?
Minus them.
I'm just going to minus 10 minus 4. What does that give me?
Plus 6.
Yeah. Absolutely. Have to have the same variable, have to have the same exponent. Always, always. To be considered like terms. Equation. Or I'm sorry, in terms of expression. Because we're not solving for anything. Okay? Now, the main thing to worry about here is try to figure out keywords. Okay, anytime you deal with a word problem, figure out what keywords means. Okay? 3 times. What does that tell me? 3 times. You know you're going to multiply something times 3. We don't know what, but we know we're multiplying something times 3. 3 times.
-3.
Oh, Oh no, those are just dashes. Sorry. I shouldn't be. Yeah, I should have. Okay, so yes, we know we're going to multiply 3 times something. We don't know what. Now, quantity. 3 times the quantity. What does quantity mean? Any ideas?
How many?
Yes. What?
Okay, if
What else?
has something to do with multiplication, doesn't have anything to do with division.
What?
I don't know.
Times? The word times? Or
Like quantity has something to do with division.
it can. It can. 3 times the quantity. Really, quantity in this terms, it's really separating what comes next. It's 3 times whatever we're doing in the second part. The second part is telling me x minus 5. Okay, so we know for a fact we're going to subtract x minus 5. We know that. So like I was saying before, the word quantity here is really separating this x minus 5. We need to find the quantity first. What if we need to find, in this terms we're minusing, and we might be adding in sometimes. Okay? So if you see that word quantity, really think about separating this part. Whatever's happening over here first, we're going to multiply 3 times it. So, yeah. Now you don't. You don't have to distribute it out. We're just trying to write down these expressions. Okay. So 3 times x minus 5. When you see that word quantity, it means you're really separating whatever part's coming next. And this is saying x minus 5. So we know we're going to do x minus 5. We know we're going to multiply 3 times something. Okay. Let's move on to the second one. Negative 2. We know we're going to multiply negative 2 times something. It says negative 2 times. Times the quantity of t plus 7. So this is really the same one as before, just different numbers. T plus 7. I know I'm going to do t plus 7. And I know I'm going to multiply negative 2 times it. So it would be written like that. Now, this last one, the product of 14 and the quantity of 8 plus w. What do you think this is going to look like? What does the word product mean? Put that up. So the product of 14. Yes, Freddie was right. Product, typically, it's going to mean multiplying times something. Okay, so the product of 14. We know we're going to multiply 14 times something. And here's this word quantity again. Remember, that's really separating the second part. And this is telling me 8 plus w. So we know we're going to add 8 plus w. All right? And that word quantity is telling me, okay, I'm going to add 8 plus w first, and then I'm going to multiply it times 14. All right?